I'm Andrew Jones. I work at Microsoft, part of the corporate engineering team, working on future supercomputing capabilities. This talk is not particularly about that today. I get invited to do these talks, and I come up with these titles, and at some point I've got to think of a talk that fits the title. And there's a lot buried in this title, even just before we get into the talk itself. So how do we get into this cloudy mess? And the we is important. I'm giving this talk, and the we in there tells you that I'm talking from the point of view of the HPC community, not necessarily from the point of view of the cloud community, although clearly I'm representing both hats. And the other thing is the second half of the second half of the title says, how is on-prem HPC going to thrive? It doesn't say, will it? And so I'm kind of prejudging the conclusion of the talk there a little bit. It should be self-evident from my normal presentational style, and certainly from that title, that this talk is very much going to be my personal perspectives and my personal opinions. Doesn't represent the views of current or past employers, or indeed anyone else. The reason for the spark for this talk is the current state of the conversation between the cloud world and the HPC world can kind of be summed up by this chart here, which is an awful lot of people shouting at each other, their opinions from one side of the room to the other, and there ain't a lot of listening going on. Some of the things in those speech bubbles are true, but most of them are a load of rubbish. And that's part of the problem, is that each side is working on the basis of false assumptions or flawed assumptions or entrenched viewpoints or whatever it is on both sides. And as I said, there's a lot of noise coming from both sides and not a lot of listening. So I'm going to try and start by giving my own personal history of how cloud has got involved in the HPC space, or how HPC space has looked at cloud, and then trying to draw some conclusions from that towards the end. So I start by dredging my memories for what I think of the early days of the crossover between cloud and HPC. And I think the first I can remember cloud appearing in HPC conferences and HPC events was around very, very late 2000s. So around 2009, 2010, you started to see cloud appearing in HPC workshops and HPC conferences and so on. I'm ignoring a whole lot of stuff that went before that around grid computing and all the rest of it. We're just talking about cloud particularly here, and particularly public cloud providers. And my own first proper crossover, first proper conversation I had around cloud was at the HPC, IDC HPC User Forum, of course, so now Hyperion Research, that was in San Diego in 2011. And I remember that because there was a great big power cut that took out a large number of states in the southwestern US. And there were a couple of people there from the public cloud companies. We had Deepak from AWS, we had Ryan from Microsoft. Deepak is still at AWS, still looking after a portfolio that includes HPC, but a much broader thing. And Ryan is back at Microsoft, having left to do a whole load of other things in the meantime. I did look up the agenda for that conference, and apparently I gave a presentation on exascale software opportunities in whatever that was, 2011, a decade and a bit before exascale turned up. I've no idea what I said or what I presented, and I'll be quite curious to find out. There doesn't seem to be any record of it. So, but the point about cloud in this time frame is it was pretty quickly and trivially easy to demonstrate the cloud was not relevant for the HPC use cases in this time frame. There were a few tiny examples where it kind of made sense, but they were really pretty rare. It fell apart on usability, it fell apart on functionality, on performance, compatibility, the support for the HPC way of doing things, the skills, etc. There was big challenges across the board. And it was a fairly easy, look, it's interesting, we'll keep an eye on it, but it's not really viable for HPC. Then you move on to the late 2010s. So you're almost a decade later, and we've still got a similar thing. So you're now into the frame where it's still a no. It's still a relatively easy no for HPC in the cloud. Usability and functionality were being delivered by this point. You could actually run HPC workloads in the cloud. It became, you get into the point where performance was evolving from being disappointing to gradually being good enough. Virtualization was getting in the way rather than helping. Networking and I/O were varying between non-existent to just poor. And scalability was non-existent except for trivially scalable workloads. But over the course of the second half of the decade, the performance issues did start to improve. and to the point where they got close enough and good enough that you could start to have a conversation. And then, of course, the attention turns to cost, which in that time frame was usually an order of magnitude worse for a cloud setting compared to an on-prem setting on a per core hour basis, which we'll get onto in a second. And there was started to also be early exploration of the HPC community of some of the ideas from cloud computing, such as containers and virtualization and so on. So taking some of the ideas of cloud and bringing them into an on-prem world. But broadly speaking, it was still a relatively easy no in most cases. So this is the era that I describe as, look, it's technically possible, but makes no sense economically. It was also the era, and the positioning of that thing at the top of the screen doesn't help reading the titles of my slides, but it was also the era where some really unhelpful messaging from the cloud companies damaged the credibility of the story they were trying to sell. Not just then, but leaves a significant heritage to now. So some of this very early marketing, poorly framed, as I say, didn't just create distrust and resentment at the time. It's left a residual distrust and resentment that's a big barrier for people to overcome even now. Even though the actual messaging, the product has improved, the messaging improved, the engagement improved, it's all much, much better now. There's still this barrier to overcome. So they did shoot themselves in the foot somewhat at the beginning. You saw this kind of thing. No need to spend millions of dollars on a supercomputer, just run it in the cloud for $200. Brilliant if you want to run 1 or 2 or 3 simulations. If you want to do some actual science and run hundreds or thousands of simulations, then it turns out you're going to be spending millions of dollars in the cloud anyways, and then there's no difference between millions of dollars in the cloud and millions on the supercomputer. Only pay for what you use, that's true, but it's just a poorly aimed message in the HPC world where you've got very high utilizations. So fundamentally, as a HPC community, traditionally we were using what we paid for or paid for what we used because the utilization was very high. And then you had a whole load of other stuff that I'm not going to go through in detail that turned up on the marketing materials or sales materials of various companies, from infinite scaling or virtually unlimited capacity or creating clusters in seconds, easier to use in legacy supercomputers, no queues, no barriers to access. Hopefully everybody in this room realizes that most of those things are rubbish. Some of them are good proxies. If you're talking about taking a single node or a single virtual instance or whatever, then yeah, relative to that scale, there is virtually unlimited capacity. Relative to somebody who's used to using supercomputers, then there is not virtually unlimited capacity in the cloud, not even close to it. And then things like no queues. I mean, we've all seen stuff in the social media recently about struggling to get access to GPUs in the cloud, for example. If you're waiting for quota and allocations, what's that if it's not a queue effectively? And the same is true of a whole load of other things like that. Creating clusters in seconds, absolutely true if you've done all of the pre-creation and all the setup work and all the rest of it, and you're just reviving an existing cluster, basically. Setting one up from scratch is a lot longer than seconds. And then you've got this kind of stuff coming through. If you don't agree that cloud is the future, then you're just a dinosaur or a tin hugger. I've never been convinced by the sales tactic of insulting your customers. If only the HPC people would do the TCO model, total cost of ownership models properly, then they would see that cloud is cheaper. So all this messaging really didn't help the case. It turns out that the cloud companies weren't the only people who were being downright awkward about this. Our friends and myself and whatever in the HPC community, and I'm as guilty as at least half of the stuff on this slide, were being particularly stubborn and intransient from the other side of the fence as well. Things like, if the cloud goes down, then our users won't be able to do any work, which can only be based on the premise that I think my HPC cluster has less outages than Gmail's had over the last however many years, which clearly is a load of rubbish. On-premise HPC clusters are nowhere near as stable as cloud infrastructure. Our system is more secure because I control it, and I don't see how it can possibly be more secure with thousands of cybersecurity professionals monitoring it 24/7. I can deliver the best science by sticking to what I know. The inertia in the HPC community is incredible. We believe ourselves as leading the forefront, and we see ourselves as the leading edge and bringing new technology and the rest of it. We are a woefully inertial community and very slow to adopt new ideas and new practices. We're great at deploying the latest new processes, fine. Technology, hardware, yes, but anything else, workflows, changes, processes, all the rest of it, concept, we're really, really bad at doing that. And so on. And then this one. If only the cloud people would do their TCO models properly, then they would see that on-prem is cheaper. Keeps coming back to TCO again. So on both sides of the fence, there's a considerable abuse of total cost of ownership to make the case you want to make. If you are measuring total cost of ownership per core hour for a reasonably stable workload, no number of cores, 1,000 cores for 3 years or whatever it is, then a dedicated on-prem system is cheaper for the same number of core hours. It is. I'm not here to challenge that. It absolutely is. If you're measuring the total cost of ownership per science delivered, then under the current format, a cloud system will deliver you more science for the same budget over time. It's true. So how can those two things be reconciled? And it comes down to the fact that a core hour is a really rubbish proxy for science delivered. It used to be a good proxy. When everybody was buying the same kind of stuff, we were all buying fixed clusters that had a 3-year lifetime. We were all buying CPUs. There was no GPUs. We were all essentially deploying InfiniBand clusters with Intel CPUs. Then what we were deploying was broadly comparable from site A to site B, or technology A to technology B, or generation A to generation B. And what you would expect from one workload's experience on this cluster to be another workload's experience on this cluster was broadly comparable. In that era, core hour was a reasonable and justifiable proxy for science output. That era doesn't exist. We've got CPUs, we've got GPUs, we've got different technologies coming into play. We've got significantly different types of technologies at different sites. We've got dynamic workloads that expect to have some time doing AI stuff, sometimes doing traditional modeling and simulation. On the other side of the fence, you have the difference between a fixed compute resource of a fixed lifetime versus, well, I'm going to use a little bit of GPUs today, a little bit of CPUs tomorrow, a lot of CPUs tomorrow. We're going to use some spot pricing the week after. We're going to use some pay-as-you-go pricing for this thing right now because we need to get it through the door because the urgency is more important than the cost of the science. And so this idea of a fixed compute unit or a fixed resource being a proxy for science is fundamentally a flawed assumption in the modern world. Clearly, my little red text at the bottom as well, there's a whole load more nuance and complexity to this, which is why usually I can deliver a whole half-day workshop on TCO models. But the point is, we're making use of TCO in the wrong way. And then you move on, continuing back to my history, into the very late 2010s. So we're talking 2018 and beyond here. Cloud is now good enough in terms of performance for actually a really wide range of workloads. There aren't that many workloads that you can't run in a cloud environment now and get decent performance out of. You have low latency networking of one kind or another provided by all of the major cloud companies. Plus, of course, you have the InfiniBand stuff from Azure that Paul talked about earlier. And those users who are more advanced or more mature or whatever phrase you want to use to try and be polite, have evolved their conversation from TCO per core hour to whole picture economics, total cost of ownership, but also total cost of solution. Looking at things like the value unlock, looking at what you can do to enable scientists to do things differently and implement the workflow, and how you protect yourself against the risk of technology uncertainty, which is very real. And then it starts to make more sense. And some of it's about cloud, and some of it's about dynamic resourcing and so on. Cloud is not kind of the ownership of all of these concepts. And so you now get this era where HPC centers are exploring, and not only exploring the techniques and technologies, but actually adopting and deploying the techniques and technologies from cloud into an on-prem world. And as I said, you see this bigger picture about integrating ML, and the fact that you can deploy resources around the world geographically, not just in one location. So to the point where it's now arguably irresponsible not to include an evaluation of cloud in your business case for HPC when you do your next refresh investment strategy, whatever you want to call it. This is not in any way to suggest that cloud is going to win, but it's now got to the point where it's such a prevalent technology, it's flawed to not include it in your business case. An evaluation of it is one of the options. And so we're in this era now where I say, realistically, both cloud and on-prem are viable options across economics and performance and usability. They coexist. One will be best for your scenario, one will be best for your scenario, one will be best for your scenario today, another one will be best for your scenario tomorrow, etc. Okay? So they're both viable things. So that's kind of where I feel we're at the moment. Let's kind of leak a little bit forward towards the future, but I just wanted to take a step back and look at what we mean by HPC and what we mean by cloud. Because again, there's assumptions built into this. High performance computing is more than just hardware. I always talk about high-performance computing, not high-performance computers. And I've been presenting a version of this slide for nearly 20 years now in various formats. Clearly it's been edited and so on. And it's been quoted in all sorts of government reports and stuff as well. But the gist of it is, this thing I push is, high-performance computing is not just a computer, or it's not about a computer. It's an engineering capability or a research capability that is built using technology, comprising hardware and software, and people and processes to deliver a benefit, an advantage to science and business. And all of those elements are important. You cannot deliver high-performance computing just focusing on the technology. You have to focus, you have to deliver the people aspect of HPC as well to actually make it deliver value. You have to have a processes around it. Who gets access? How? When? What are they allowed to do with it? What are they not allowed to do with it? What's your policy around energy efficiency for the applications, for example? And importantly, you can have the most perfectly run HPC system in the world with all of the people supporting it, with great applications on it and some brilliant quota processes and everything else. If the business or the science does not take advantage of that to deliver the impact to the business or to deliver the right kind of science, or for the company to make the right drilling decisions or the right fleet routing decisions based on the output from those capabilities, then you're not doing high performance computing, you're just doing lots of pretty heating of copper wires and silicon chips and all of the rest of it. So the bottom line is important as well. You have to actually deliver it into the science and the business. And that means that the success in high-performance computing really depends upon your ability to identify advantages, whether those are technical advantages or people advantages or processes, and to deliver them into the business, into the science, and how well you're able to deliver that impact to the business and science. So you're looking at things like the friction, the ease of use, the enablement, the ease of access to it, and so on. And all of that includes the things we're very much used to, like how do you pick the next processor, how do you pick the next interconnect, and so on. But that's one tiny little stripe of all of what you need to do to be good at high-performance computing. So let's look at the other side of the equation. What is cloud? The cloud. There is no such thing as the cloud. Various companies have chosen to sell a product, usually a service, and call it cloud and brand it. So cloud is a brand. It's a technology, maybe, a combination of technologies. It's a business model. As I said, it's a branding. It's offering something as a service. But the cloud, as a thing, doesn't really exist. Cloud is shorthand for Amazon, Azure, and Google. Yeah, pretty much. The only people who disagree with that are the people with on-prem clusters desperately trying to blag that they are private clouds. But realistically, most people, common usage, cloud now means those three companies. Cloud is just a large capacity of loosely connected virtual machines. Yeah, I mean, that exists, but only as a minimal baseline. All of the main cloud providers offer, when we're talking the HPC context, all of the main cloud providers offer something significantly more than that for the HPC community. Cloud's cloud. Doesn't matter who's you use, they're all the same. Commodity, multi-cloud is obvious. Not even close to being true. Not even close. Even apart from the different interfaces and APIs and workflow models and all the rest of it, moving workload from one cloud to another, you pretty quickly realize that's not true. The only way you're going to get anything close to the truth out of that statement is if you abstract away to the lowest common denominator and essentially throw away the advantages not only of each cloud, but of actually using the cloud in the first place. So there is value in multi-cloud, which is about picking the best components of each cloud provider. But then you've got to look at the overhead of integrating all that together to build your service to your user community and so on. And it's not usually a sensible thing to do. Cloud is just somebody else's computer. Yup. Welcome to HPC. For almost everybody who uses a supercomputer, it's somebody else's supercomputer. If you're using the National HPC facility, Archer, it's somebody else's it's EPSRC's supercomputer that you're using that's run by Edinburgh. The Dirac facility, if you're a user of that, it's somebody else's supercomputer that you're using. If you're a user in Cambridge using Paul's computer, it's somebody else's computer. Even within an institution, it's somebody else's computer. Somebody else is setting the policies and looking after your data and providing access to other users to what is not your computer and so on. Same is true as an industry, doesn't matter else. So the fact that somebody else's computer, frankly, that is HPC and always has been. I'd also like to point out that there's also no magic about cloud. People often wave at it like, cloud is this thing that's going to solve everybody's problems. It ain't. I mean, we heard this morning that, or just after lunch today, Azure HPC is just a bunch of InfiniBand clusters, exactly the same as we deploy an on-premises data center, plus associated storage and network and da-da-da. The only difference is instead of deploying one of them, we're deploying lots of them all around the world, and there's lots of scale and so on. But other than that, it's the same stuff. There's no magic to it. So, if you kind of take all that together, the idea about agility and what HPC is and what HPC isn't, and cloud is and cloud isn't, you can pretty easily draw up a set of situations where on-premises makes perfect sense and where cloud makes perfect sense. And I'm not going to go through this chart in detail, but essentially if your context and your knowledge of your workload and your funding situation and so on drives you onto the right-hand edge of that chart, right hand for me, left-hand edge of you on the red side, then an on-premises system is probably going to make most sense for you. If you're driven more towards the right-hand edge of the chart, so the blue side of the chart, in terms of what you want to do and what makes value statements to you and so on, then broadly speaking, you're going to end up with cloud as a solution. The catch is, and this is the hard part, most of the things that differentiate cloud and sell the value of a cloud capability are things that undeniably are true. Agility is undeniably a value that delivers extra value to science because you can adopt new technologies more quickly in year and so on and so on. The ability to protect against technical risks is a genuine value. The problem is, how do you measure them and quantify them? And this is why when we talk about people use TCO models and abuse TCO models, it's fundamentally because cost models are easy. Value models, which is the other side of the equation, are way harder to build. But they're important. So I don't know if you've seen, I haven't got it in this deck, but you've sometimes seen me present another slide where I talk about using a TCO to make the decision about a new technology or whatever is like using one team's score in a football match to try and figure out the result. If you don't know the other team's score, you cannot judge the winner of the competition, the winner of the match. And it's using a TCO model alone without a value model is only using half the information. The other point I'd make is that you see these studies from Hyperion and others saying that return on investment for HPC is something like 80 to 1 or pick your number. 4,300. Yeah, exactly, hundreds to 1. But it doesn't matter what it is. Let's go with the 80 to 1 because it's a lot more conservative than the 500 to 1 nonsense you sometimes see. Why do you spend all your time focusing on tuning the 1 and not the 80? Because a 10% swing in the 80 is bigger than a 50% swing in the 1. The value side of the equation is much more powerful than the cost side of the equation. It goes back to where we are as an industry, HPC industry, community, we're actually really bad at adopting to these newer thinkings. So, my guess at the future of HPC and cloud. HPC will be nearly 100% cloud. Doesn't put a time frame on it, but let's call it within a couple of years. Now, as you might expect from me, it's never quite that simple. So the major cloud providers are going to continue to improve their offerings. Customers will find a great story for use cases, big picture economics, performance, whatever it is, risk implications. And so the number of users in the cloud will grow. The few remaining significant on-prem vendors, and that's a challenge, there are fewer and fewer quality vendors at scale delivering on-prem solutions. At some point, they're just going to brand all of their offerings as cloud anyways. They've already started it realistically. Both in terms of the vendors pitching what they're selling as a on-premises cloud hardware sale and HPC centers branding what they're doing as private cloud and so on. So what I really mean to change the title is HPC will be nearly 100% called cloud within a couple of years. Not all things going to the cloud. That's not going to happen. The other point is that I think at some point in the next few years, only a few people are still going to care about the label. So who's going to care whether it's called cloud or not? The people who need to be seen to be in the cloud, like, some CIOs and so on who have got a transformation agenda to drive will need to be seen to be in the cloud. People who define themselves by running a HPC center will care about the label. The poor souls who have to write the contracts and the RFP documents from all this stuff will care about it on the user guides. And people like Dan, the analysts, will care about these labels because they sell you the how much people are moving to the cloud and so on. At some point, and maybe I'm optimistic, the rest of us who are just trying to do science or do business or whatever it is or provide a solution and service to our users are going to get focused on how do I use the range of technologies available to me, the range of providers available to me to deliver the best impact at an acceptable cost, and at some point we're going to lose interest in this label of whose data center it's in. That's a long way from reality. I'm not going to drain that final box, but there's a lot of work to get there. There's a lot of promises on both sides that aren't necessarily met with reality at the moment. There's a lot of expectations. There's a lot of thorny issues and real issues in there to figure out. You know, most HPC centers have sunk costs in a data center. You can't just write that off because it's a little bit cheaper to use the cloud for one particular context in the next year or so. So there's a lot of stuff to work through to get to this point. And so some takeaways, if you like, from my ranting, rambling, or however you wish to describe this attempt at a talk. Cloud is moving at least as fast as HPC. At least as fast as HPC at the moment. It moved slowly. That first decade, not a lot happened. But in the last few years, the last 2 or 3 years, it has radically really changed significantly in terms of what's provided and engagement models. If you are basing your opinion or assumption or evaluation of cloud for HPC on information that's more than a year old, more than about 6 months old to be honest, but certainly more than a year old, then your assessment is out of date and fundamentally flawed. That's the pace of change going on. That does not mean cloud is best or wins across the board. Far from it. Far from it. And this is the other key point. On-premises HPC has got a long-term future. There are plenty of use cases where the workloads are predictable, the workloads are stable, the workloads are known, or we can take a reasonable guess at what our future users look like. The immediate cost is a stronger driver than agility, for example, or you're willing to tolerate the black swan events of the risks you're trying to protect against. Or the cost of change is very high. You've got a huge sunk cost in a data center, a huge sunk cost in an application workload, or in the skills of the people, for example, and so on. So on-prem HPC is going to thrive for the foreseeable future. I did dither over that word for a long time, whether I should say on-prem HPC is going to survive or thrive for the long term. But I think it's thrive. I think it's not going away soon. But ultimately, what the whole point of this talk is about is forget about the labels. Both labels, the on-prem label and the cloud label, forget about them because they don't really matter. What really matters are the capabilities, the performance, the risk, the agility, the economics of any given solution or provider for your particular context, which may change over time. You know, whether that's your particular project, your organizational culture, the funding constraints of where you are this year, where you might be next year, and so on, and the workflow models and the skills and all the rest of it. And so if we just focus on that as a community, which frankly we're rubbish at, focusing on the output and the science we're delivering, the best way to typify the HPC community is that we all do this, and all of us, I can see people in the audience who I know have done this and are nodding away or not nodding away or trying to not look me in the eye, all stand up and say, it's all about the science what matters. And then there's 23 slides about the hardware. And that really describes the HPC community. We are actually so difficult. We talk about the talk, but actually when it comes down to it, we're all focused on the hardware. And I'm no worse, I'm no better than anybody else. I do the same as well. So that's my little rant and a little bit of fun.
Thank you very much.